Today is September 24th, 2016. Today's presentation, the two objects draining the sun of its energy, a physicist's thoughts. Let's begin. I have previously written about the object and the H12 SREM-A images and that it fits the profile of a brown dwarf star, having CMEs, coronal mass ejections, which are made up of ionized iron. Figure 1 below shows this object, which seems to be parked in front of the baffle on January 23rd, 2016 and February 9th, 2016. The black areas in the image are associated to proton emission, and the white areas are associated to heavy ion emission, in this case mostly iron ions. The brown dwarf is made mostly up of iron, and therefore its CMEs must also be made up of mainly iron. Notice that there is a cloud and a vertical line somewhere in the middle of both images. Both the cloud and the vertical line are white and therefore must be made up of ionized iron that had been ejected by the brown dwarf. Figure 1. H12 SREM-A images provided by Secchi from January 23, 2016 at 1809 UTC and February 9th, 2016 at 1609. The object in front of the baffle does not seem to move from that position. Figure 2, H12 SREM-A image as provided by Secchi from August 16, 2016 at 2:09 UTC, showing ionized iron being ejected from the brown dwarf. Ionized iron cloud moving diagonally upwards. Ionized iron ejected from the brown dwarf. Right? You can see all the white. Ionized iron cloud moving diagonally upwards, so you can see it going like this. Figure 2 above shows the ionized iron being ejected from the brown dwarf. The iron is ejected from both the left and the right baffle sides of the object. The ionized iron then moves diagonally downwards towards the right and also upwards towards the left. Towards the top of the screen, some of the ionized iron moves vertically downwards and a vertical white line forms in the image as seen in Figure 3. This suggests that there is a highly charged object somewhere along this line that attracts the ionized iron. Figure 3, H12 SREM-A images as provided by Secchi from September 14th, 15th, 17th, 18th, and 18th of 2016, showing where the ionized iron goes after being ejected from the brown dwarf. The rest of the ionized iron moves toward the top left of the screen, and from there toward the sun's north pole. It then spreads around the sun. Figure 4 points out where we can see the ionized iron accumulating around the sun. White is always associated to heavy iron emissions, so a white area is an area where ionized iron has accumulated. When enough of this iron accumulates in the sun's atmosphere, fusion reactions stop on the sun's surface and it goes dark. However, the sun seems at times to be able to also eject large amounts of ionized iron, as can be seen from Figure 5 below. Here the sun has what can easily be termed as an explosion, and large amounts of matter is ejected. Most of the matter appears white, which is associated with heavy iron emission or ionized iron emission in the SREM images. The black regions are due to the ejection of protons, so the sun also loses protons when it goes through this kind of explosive episode. Figure 6 shows another such explosive episode where, again, The sun ejects large amounts of ionized iron that is accumulated on its surface in its atmosphere due to the presence of the brown dwarf. Figure 4, here on the left, ionized iron making its way towards the sun's north pole. Ionized iron accumulating close to the sun. Figure 4, illustration of how the ionized iron is getting to and accumulating on the sun. This image is the last image in figure 3. This is figure 5. H12 SREM A images as provided by Sechi from July 18, 2016 at 1317, 1717, 1809, and 2009 UTC. The 1717 and 1809 images show that the sun goes through an explosive episode in which large amounts of heavy ions, white regions, i.e. iron ions, are ejected. Wow. Figure 6. H12 SREM A images as provided by Sechi from July 13, 2016 at 209, 409, 609 UTC. The sun first ejects a large amount of ionized iron at 209. Then it ejects a large amount of protons at 409. And finally, a large cloud of ionized iron is left between the sun and the brown dwarf. Figure 6 also shows that when the sun ejects large amounts of ionized iron, or iron ions, quite a large amount follows the vertical line in the middle of the image, down towards the bottom of the image. This is an indication that there is an object down in that area that is attracting the ionized iron. Whoa, dude. This is getting heavy, man. Since the sun is able to eject ionized iron in large quantities, it should be able to prevent its surface from being flooded with iron and going dark. It is strange that the sun is actually going dark for about an hour a day for 24 days every 184 days. It cannot be only the presence of the brown dwarf as being the cause for the sun going dark. If that was the case, the sun would not be going dark on a regular cycle. It would just happen now and then, whenever the ionized iron on its surface got to be too much and nuclear fusion stopped on the sun's surface. Wow! Figure 7, object photographed from the Earth's surface, thought to be the planet Nibiru, which orbits the star Nemesis, from a Jeff P. video. I'll put the link below. This planet is a highly charged object as it is surrounded by plasma and has 2 plasma tails. This object appears and disappears and also seems to change color. The disappearing and color change effect is probably due to its undergoing a constantly changing plasma discharge. The only explanation is that there is another highly charged body that is closely passing by the sun every 184 days. The brown dwarf has to be in orbit around the sun in order for it to be in constant view of Stereo A's camera, but this other object does not have to orbit the sun. It could be that it orbits the central star of the larger star system that the sun finds itself a part of at the moment. Figure 7 shows an object photographed from the Earth's surface, which is a good candidate for the object that would affect the sun to the point that it is not able to eject ionized iron and so goes dark for a period of time. Now this planet, Nibiru, is thought to have a positive and negative plasma tail. Since the sun is an A node, a plasma discharge from Nibiru's negative plasma tail would neutralize the sun for a period of time and stop the sun from being able to eject ionized iron. It is also possible that the negative plasma discharge is able to directly stop the nuclear fusion reactions, even if there is no iron on the sun's surface, though. But it has to be that the combination of the presence of iron and the negative plasma discharge compounds the sun's energy drain. The fact that the sun goes dark about once every 24 hours suggests that this object has a near 24-hour rotational period. Then, as it makes its pass close to the sun for a period of 24 days out of its 184-day orbital period, it discharges negative plasma towards the sun, which causes the sun to go dark about once every 24 hours. In other words, for a period of 24 days, this object is close enough to the sun so that when its plasma tail is in the correct position, i.e. pointing towards the sun, probably for about an hour, every 24-hour period, the sun's surface charge is neutralized. Fusion ceases and it goes dark. Very matter of fact. In conclusion, the sun seems to be getting drained of its energy due to the effect of two objects in our solar system that have come into close proximity to it. One is a brown dwarf star that floods the sun with ionized iron. This iron can either accumulate in the sun's core or it is ejected. But to eject the ionized iron, the sun uses up a lot of protons, which are its main fuel source. But to eject the ionized iron, thus the sun is increasing its iron level, which it cannot use as fuel, and it is losing protons, which are its primary fuel source. This causes the sun to get dimmer, weaker, and older. On the other hand, the brown dwarf is rejuvenating because it is capturing protons from the sun and is therefore able to restart fusion reactions on its surface and produce light. Secondly, the highly charged object, the planet Nibiru, makes its pass close to the sun 184 days and neutralizes the sun's positive charge by flooding it with negative charge from its negative plasma tail. This has the effect of producing the darkening effect as observed by the SDO satellite, which I have written about previously up at the link below. Also, when the sun's positive charge is neutralized in this manner, its electromagnetic field is affected and is progressively weakened through subsequent darkening episodes. A physicist's thoughts. Have a good day. Bye.